Hello and welcome back to Math with Mrs. Becker. This is Algebra 2. We are looking at the second part of Chapter 1, Section 3, pertaining to square roots. Okay, so for day 2, we want to focus if a fraction has a denominator. And remember, a denominator, that is the bottom of the fraction. When you have a fraction, the top is called the numerator, the bottom is called the denominator. Okay, so just for a quick review. So if a fraction has a denominator that is a square root, you can simplify it by doing something that is called rationalizing the denominator. Okay, so what this tells us is we cannot leave a square root in the denominator of a fraction. If we have that, we have to go ahead and do what's called rationalizing the denominator. To do this, you multiply both the numerator and the denominator by a number that produces a perfect square under the radical sign in the denominator. So let's go ahead and see what this looks like, okay? Now the properties from the first part of 1.3, remember you could go from 2 radicals on top and bottom to 1. However, if I did that 5 over 2, that's really not going to help me much, okay? So even if I tried that other method, we would end up with what we're starting with, okay? So I do have a radical on the bottom of the fraction. It contains a square root, and what we learned in the first part is not going to help me. So what I need to do is multiply the top and the bottom of the fraction by the radical that's in the denominator, okay? When you multiply radicals, the outside number goes with the outside number, the radicand, the inside goes with the inside. Now this square root of 2 did not have a number out front. If it helps you, you can put a 1, because now I can say 3 times 1 is 3 on the outside, 5 times 2 is 10 on the inside. Bottom, the square root, 2 times 2 is 4. Well, check this out. 3 square roots of 10, the square root of 4 is 2. You no longer have a square root on the bottom. Now 10, I cannot simplify a 10 any further because 10 is created from 2 times 5. And remember, in order to take a number outside of a radical, you do have to have 2 of the same value. Okay, I can't cross off a pair of 2's. Let's look at that again. If I were to go from 2 symbols into 1, I'd have the fraction 5 over 7. That really doesn't help me at all, okay? So what I need to do is rationalize the denominator. You multiply top and bottom, numerator and denominator, by the radical that's in the bottom. On the top, outside number times outside number. This is an unwritten 1. 3 times 1 is 3. Under the square root, radicand times radicand. 5 times 7 is 35. Bottom, square root of 7 times square root of 7 is the square root of 49. Now on the bottom, it should always be a perfect square root. The square root of 49 is 7. 35 cannot be broken down because it was created from 5 times 7. There are no pairs of numbers. Let's keep looking. Now, there are times, though, you have to realize that sometimes what we did at the beginning of 1.3 is still the best option, and that's what I wanted to show you here. Yes, I have 2 symbols, but if I go to 1 symbol, I can simplify 2 over 8. I can divide them both by 2, and that gives me the square root of 1 over 4. 1 is a perfect square. 4 is a perfect square. So now it would be beneficial to go ahead and separate it so I have a square root on the top and the bottom. The square root of 1 is 1. The square root of 4 is 2. So just because we learned a new technique today doesn't mean that what we learned last week isn't going to be more helpful in some cases, okay? We're just adding more tools to our toolbox. It doesn't mean that what you previously learned, we no longer apply. Now we just have more things we can do, okay? Now if I look here, I only have 1 radical, so I don't have the option like I had in the top example. I can't turn it into 5 over 10 under 1 radical. The only one that I have is on the bottom. I can't simplify 10 because it's 2 times 5. I don't have any pairs of numbers I can cross off. So I need to multiply top and bottom by the square root of 10. Remember, when you multiply, outside goes with outside, inside goes with inside. So 5 is on the outside, 10 stays underneath. So that's 5 square roots of 10. Bottom, square root of 10 times the square root of 10 is the square root of 100. The denominator should always be a perfect square. The square root of 100 is 10. Here's one other thing we need to look at. Numbers that are not underneath the radical. You need to look at them as a fraction. And what that means is you can simplify it. Whatever's under the radical, don't worry about. But 5 over 10, I can divide top and bottom by 5. 5 divided by 5 is 1, so I'd have 1 square root of 10. 10 divided by 5 is 2. So this is your simplified solution. If you wanted, you could go 1 square root of 10 over 2, same thing. Okay, just like if you have x, x is the same thing as 1x, same thing with radicals. The square root of 10 is the same as 1 square root of 10. Okay, now here's a really cool idea. Square roots that have the same radicand, and remember the radicand is the value that's underneath the symbol. They are called like radicals. You can add and subtract square roots as long as they do have the same radicand. What you do is you keep the square root portion the same, and you add or subtract the numbers out front. Okay, so these are examples of like radicals. This is a square root of 2, this is a square root of 2. Underneath the symbol, they both have a 15. These both have 1a and 2 b's. Unlike radicals, this has a 5 underneath and a 2 underneath. It's not the same. This is an x and a 3x. They don't match. This is 1x, 2y, so this is 2x, 1y. Okay, so in order to combine them, you have to have the exact same thing. It's very similar to like if I took 2x plus 3x, 2x plus 3x is 5x. The x's stayed the same, you just add the numbers in the front, okay? If I have 2 square roots of 3 plus 3 square roots of 3, I keep the square root of 3 the same. I add the 2 and the 3, making it 5 square roots of 3. So very similar to adding and subtracting like terms when we're working with variables. It's just that we have a radical this time. The number or variable, whatever's underneath it, has to be the same. Okay, let's go ahead and look at this. This is a square root of 3. This is a square root of 3. So I can combine them, but you do not change the square root of 3. What you add are the numbers in front. 9 plus 7 is 16. Your answer is 16 square roots of 3. This is a square root of 5. This is a square root of 5. The square root of 5 does not change. 3 plus 10 is 13. Okay, there are times, though, where you have to simplify first. Like 5 can't be broken down, but 20 can. 20 is 2 times 10, and 10 is 2 times 5. I know I can simplify it because I have 2 2's. So the 5 stays, so 6 square roots of 5 minus. But remember, if you can cross off 2 of one value, you get to write that one time on the outside. The 5 could not be crossed off. So the square root of 20 is really 2 square roots of 5. Now I can subtract them. Square root of 5 and square root of 5, the square root of 5 stays the same. 6 minus 2 is 4. So I have 4 square roots of 5. Same thing here, 80. 80 is not broken down. 80 is 8 times 10. 8 is 2 times 4. 4 is 2 times 2. 10 is 2 times 5. Okay, so anytime I can cross off 2, I get to write 1. Cross off 2, I get to write 1. 5 is stuck. I ended up writing more than one number on the outside. I wrote a 2 for this pair and a 2 for this pair. Remember, you multiply them. 2 times 2 is 4, so this is really 4 square roots of 5 minus 5 square roots of 5. Now they are both square roots of 5, so I can keep that. 4 minus 5 is negative 1, or remember, you would not have to necessarily show that 1. You could just have a negative square root of 5. So that is the second part of 1.3. Here's what the book assignment is. You are going to complete numbers 10 through 17, 30 to 42, 48 to 53. You can find that in your textbook on pages 24 and 25. So what we did from 1.3, granted we did this over a couple days, you completed 1 through 42 and 48 to 53. But your assignment for today is just this part 2, because you have already done part 1. I hope today's notes made sense. I hope you enjoyed our time together. I'll talk to you tomorrow.